today's lecture, I will be doing one more problem on separable kernel, and that is y of x is equal to lambda integral from 0 to 1 to e raised to power of x plus t y of t dt. Now here 2e raised to power of x plus t is my separable kernel, okay here. So, but I will write it as q of x comma t is equal to 2 e raised to power of x into e raised to power of t. Separable is my separable kernel, okay. Now y of x is equal to lambda integral from 0 to 1. Now what is my q of x comma t kernel? I am going to write it as 2 e into e raised to power of x into e raised to power of t y of t dt. Now since this is with respect to dt, meaning with respect to t, I will remove this x term, wherever there is x variable, I will take it outside. So lambda 2e raised to power of x, I will take it outside the integral. So y of x is equal to 2 lambda e raised to power of x, I have taken it outside the integral from 0 to 1 e raised to power of t y of t dt, and consider this as equation 1. Next, put c is equal to wherever this has c, okay. So c is equal to integral from 0 to 1 e raised to power of t y of t dt I have to put, okay, and consider this as 2. Then y of x, now this equation will become what? Y of x is equal to 2c, this part is what I have taken it as c, 2c lambda e raised to power of x, and consider this as 3. Now what I have done is from 2 what I am going to get from this equation, what I will get, c is equal to integral from 0 to 1 e raised to power of t. What is my y of t dt? Now this is in terms of y of x, but if it is in terms of t, then 2c lambda e raised to power of t I will get, right? So that's what I have to plug here, 2 lambda c raised to power of t dt. Then take this 2 lambda c outside the integral. Then integral from 0 to 1 e raised to power of t into e raised to power of t is nothing but e raised to power of 2t dt. And now what is the integral of this? The integral for this is this, no, e raised to power of 2t upon 2. So I'll turn the page and I'll do on the next page. So yeah, so c is equal to 2 lambda, and then what is this? C is there, right? Just put c over here, okay. There was a 2 lambda c, and what is the integral? E raised to power of 2t upon 2, and the limit is from 0 to 1. So I have to do upper limit minus the lower limit here. But this 2 I will take it outside, so 2 will get cancelled, okay. Now if I take this 2 here, so this 2 and this 2 will get cancelled, okay. What we will get is this is equal to lambda c e raised to power of 2 minus 1, okay. Now this implies what? Lambda is equal to what? Here c was there, right? So lambda is equal to 1 upon this, because c upon c will get cancelled and this will go down, right? So I will get e square minus 1. Lambda is equal to 1 upon e square minus 1. Now what I have to do is I have to plug this equation in this. In equation 3, y of x is equal to 2c lambda e raised to power of x. Y of x is equal to 2c e raised to power of x. Now what is this? Lambda. Instead of lambda you have to put 1 upon e square minus 1, because we have to find the value of lambda and we have to plug it here. So I will end up my lecture here only, and the next and one more video I have uploaded in the separable problem. Sorry, separable kernel problem, okay. And if you have not understood any of the part, you can just comment below, and thanks for watching.